very exciting to be here again. I'm told about half the audience are representing technology or entrepreneurial companies. As entrepreneurs, we dream about creating the disruptive change that's going to change the world. Clearly, we think differently than most other people. Most of you probably remember the Think Different campaign from Apple a while ago. We think the right frame of thinking for a product is to think not just differently, but to think complete. Conventional wisdom is that the first entrants in any industry never really succeed. What we've learned in our short life as a company is that the first complete product actually succeeds. So what I'm going to do is take you through a couple of historical examples and talk about the view story relative to how we think about the product. Okay, so going back to over 100 years ago, and I've always had a big interest in automobiles. People tried to introduce steam engines into automobiles. They used to be used for trains and other things. That didn't go all that well. And in fact, that novel change never really beat the horse-drawn buggy. And the reason for that is when you put a steam engine in an automobile, it was pretty clunky. It was actually quite dangerous. You had this explosive steam engine sitting right next to people. People were uncomfortable, and it never really took off. Fast forward to about 1880 or so, Carl Benz came along. This is the Benz of Mercedes-Benz. And he invented the two-stroke internal combustion engine that ran on gasoline. And that change, that single change, brought about an era of a lot of innovation. And it truly is still the mode of transportation we know today, powered by gasoline and diesel and so on. Fast forward another 100 years or so, or a little over 100 years, we come to Elon Musk and Tesla. Now, to be clear, Tesla was not the first company to invent the electric car motor. In fact, this concept is over 100 years old. But Tesla, we believe, was the first company that made it a complete electric car. So let's spend a minute on what's a complete electric car. It has 4 doors. It's safe. You can put your family in it. It goes over 200-mile range, maybe 300 if you have the right size battery. And you can really use it as a day-to-day car. It looks and drives and feels like a regular car. Now, the Model S is more of a luxury car. I know the Model 3 just got introduced. But we can all feel now that this type of change to an electric automobile that makes a complete product rather than a clunky thing, that makes it truly able to create that disruption in a way that creates the tipping point to an irreversible change. Okay, let's go look at another industry, communication. Alexander Graham Bell came up with or invented the telephone. So until the telephone came about, people could only communicate with people that were right in front of them. But with the telephone now, with a microphone and a speaker, you could talk to pretty much people anywhere. This is still the technology we still use today, a speaker and a microphone, right? Fast forward to Steve Jobs and the famous smartphone with the iPhone. The iPhone is the first complete smartphone. There were smartphones before this. But this smartphone, people could feel when they touched it, when they used it, that this is going to bring about a change. That same kind of tipping point and irreversible change that was possible now in telephony in a way that people didn't imagine before, by creating a complete product that had the right user experience and all the attributes that made this change irreversible. So now I'm going to talk about the view story a little bit. Obviously, context matters. You can't just make our product like you make a car or a telephone. So at View, we make this product called dynamic glass. So let me take a minute to really introduce what dynamic glass is. As humans, we spend 90% of our time, plus minus, in a building, whether it's our home or place of work or things in between. Now, shelter, by definition, is created to create the disconnection to the environment, right? It should protect you from the elements. But if you fully disconnect, you go crazy. We need some light and views for our body and our mind. So we came up with this thing called the window. And there's this magical material we use called glass that acts as a solid. It separates us from the elements and still lets in natural light and provides views. Except there's a couple of issues: heat and glare. So the same thing that gives us this beautiful experience also causes some issues for people and for buildings. So to control glare, we've been using these clunky things called blinds. And the fact that we call them blinds says something about how we feel about them. Turns out some 60% of the building windows are permanently covered with blinds. So you put the window to bring natural light and views, and you just lost almost 2/3 of that surface. So we looked at this day-to-day object and said, there's got to be a better way. What if you can have that beautiful view and light, but you get rid of the heat and glare and be able to experience nature from inside while being protected and be comfortable thermally and visually? So what I'm going to show you is how our product works. And as Joel pointed out, we're now in about 20 million square feet of space with about 20,000 people enjoying our product every single day, most of it right here in North America. So here's an example, a video that is sped up to show how the building reacts as the sun is moving around, or the Earth is moving around the sun throughout the day. So on the left side is the south-facing set of windows. On the right side are the west-facing windows. And so here in North America, the south and the west see most of the sun most of the day. And this happened to be a sunny day. And you see that as the sun comes up on the south side is tinted. And as the sun moves over to the west side, the south side is becoming clearer, and the west side is tinting. Pretty simple, pretty obvious, no blinds or shades, right? Pretty cool product, we think so anyway. So how do we do this? It's kind of magical, right? So how do we create this magic? This company is about 9 years old. We have over 500 patents, a lot of deep technology involved in this. The first part of it is the panel, the glass panel itself. It's an active panel that reacts to a command. But inside the panel is this smart coating. This is deep nanotechnology. There's multiple layers of this coating, and the total thickness of this is 1 micrometer. And for those of you that don't think in nano and micro levels of measurements every day, a micrometer is 1/50th the thickness of the human hair that you can barely feel. And we need to apply it uniformly across very, very large sheets of glass, up to 60 square feet of them. So pretty hard technology. We perfected it so we could now bring it to scale. In manufacturing this, every panel we make has a little barcode. We can uniquely identify every piece of glass that goes out of our factory, and we know exactly which building, which corner, which window it's in. And we measure 12 million data points for every piece of glass that goes out of our factory, and you can now multiply by the thousands of windows that go into each of the buildings. So pretty complex stuff. But that's really one of 3 key parts of our product. The second part are the controls. So these are 21st century digital controls. Every one of those panels is mated with a microcontroller. And the microcontroller really tells the panel what to do. But the microcontroller takes commands from a central control system that's in the building, which then connects into a network operation center. And you can control it through your building management system or your smartphone or other devices. So it's really a combination of the 3 things. It's the panel, it's the hardware that forms the controls, and it's the software and the network operation center. It's really a perfect combination of what I call atoms and bits, right? So that's the complex stuff. But when we think about the complete product, we really wanted to distill them down, all the attributes down to 3 key things that really matter within our context of what we're trying to do in this market. The first one, and most important, is the user experience. It's the person in the space, enjoying the space, interacting with the environment. And at View, we have a very simple mission. We don't say we make the smartest glass in the world. We don't say we make the smartest controls in the world. We don't say we make the most connected buildings in the world. We say we create delightful human environments. So our goal every day in everything we do is to make sure that that user, when they walk into that environment, that they're delighted, that the controls are intuitive, that the things are being controlled for them, and if they want to override, the system can learn from what they want to do, right? Very, very simple principle, hard to do for a very complex product, but we hide all the complexity behind so that all that the user sees is a window that looks like a regular window. Remember the car that looked like a regular car, and it's very, very intuitive. The second aspect of the product that we worked on to create completeness is installation. We are in the real estate industry. We are a supplier to the construction industry. So we don't forget that. While we're creating this user experience, it's critically important that we deliver the product in a way that it can scale in that industry. So there are really two critical factors there. One is ease of installation. We just want to make it so easy to put it together just like Lego blocks. So while there's a lot of wiring involved, there's a lot of low voltage wiring with our product, there is no crimping of wires. Every connector is pre-made, shipped to the site, so it comes together like building blocks. The second aspect is we didn't want to build this complete product and have to train a whole bunch of new trades to go install it, right? So we said, how do we fit into the existing value chain in the construction industry? And that starts with contracting and where we fit in the value chain, but importantly, being able to use the same trades that exist on the job sites. So in our case, there are two key trades that need to come together to put our product together. So the first are window installers. They're also called glaziers in the construction industry, in the commercial industry. The second are low voltage technicians, people that connect the wires and connect it to our control system. So, but at the end, it comes together much like a lot of other building systems, and it looks and feels like any other regular window. So that's the second thing. The third aspect of our product we focused on is reliability. I grew up in a family business. My father taught me that when you build a business, you don't just build a product or a service, you're really building a reputation. And in our case, that means this product has to last 40 or 50 years, the lifetime expectation of a regular window. Just because we're bringing something high-tech, if we start making excuses about how long this might last, or it feels more like a consumable, that's not going to fly. It won't be scalable. So right at the beginning, going back 9 years ago, when we were thinking concepts, those coatings that I talked about, the controls, and how it's installed, we had to fundamentally think about what creates durability eventually. Because the thing we care about is this thing stays up and running for 40 or 50 years in real buildings. And interestingly, this is a product that you can't hide. It's very visible. So we know that it really represents who we are out in the market. So starting with that coating, that nano coating I talked about, we used inorganic ceramic materials. And those of you that know a little bit about material science, inorganic materials are fundamentally more durable than, let's say, organic materials. The world of dynamic glass or electrochromic systems, some 90% of the work is actually done on organic materials. Turns out they're easier to engineer. But when you expose them to UV or high temperature, which is what these windows are going to be blasted with day in and day out with the sun, they start to degrade a little by little every day, every year. So we said early on that there's no way we can stand behind this product and think that it's complete if this is not inherently durable. We have an R&D facility right here in Milpitas. It's about a 75,000-foot facility. We call it make and break. Everything that's made in that facility gets broken. It doesn't get shipped out. And we test everything we make and everything we test for changes with, and we test it to fail. One of the most common mistakes we've seen entrepreneurs make is they look at these standards and they test to make sure that you pass the standard. But what they forget to ask is, where's the cliff? How and when does it break? So we created these torture chambers for our product. We increased the temperature beyond its expected normal use. We cycle it more rapidly. We pump in higher voltage. We throw in higher amount of UV. We throw salt water at it. So our goal, again, is to build this reputation, build reliability into the product, and not just pass somebody's test, because we got to stand behind it and create this irreversible change, a tipping point that makes the industry use this as a mainstream product. So bringing it together, while there are many, many attributes to these products, and there's a lot of complexity, in our case, the way we internalized it is with these 3 key attributes. So that's our view story and how we think about a complete product. Thank you very much.